I think I'm up and rolling. Hello from Centralia, Washington. Sweet. Yeah, let me know if you can also see the live stream camera footage I have here from Mauna Loa. If the screen share is working as well, that would be super. And assuming also you can hear me okay. Pull up the little chat thing. Hello, Roger. Hope everyone had a good weekend. Getting ready for the holidays, whatnot. Some of you are in warmer locations than I am, although it wasn't bad this weekend. I actually got out. Some of you will find this maybe not appalling, but a little crazy. Avid rock climber, as you may know. And so what's a little known secret here in Southern Idaho is you can, on these sunny days where there's not much wind, and even though it's kind of chilly out, you know, in the 30s or so, if you get on a real, like a southwest facing section of rock midday, the rock just radiates that heat and makes it pretty nice. So I actually went rock climbing on Saturday, hoping to go again if the conditions allow. All right, more folks rolling in. Let's see, Dave, Bill in Denver. Susan in North Central Idaho, hello. Steve in Northern Idaho. Sharon, let's see, Malaga Slide, Washington. Some of these places I need to look up on a map, not familiar. Jesus from Northern California, good afternoon. Great, looks like it's rolling here. We got about like 7 or 8 minutes on my watch, so just kind of settle in. Hope you've digested maybe some volcano info over the weekend, but if you haven't, I'm here to catch you up on things, give you a little bit of an update, maybe provide some perspective, answer some questions. Happy to help. I was gonna, I'm diving into all this USGS and other scientific information anyway, so it just makes sense for me to pay it forward, distill that information down to you folks, and maybe provide some perspective and enrichment to you. Boy, more people coming in. This is great. Let's see, Mike in North Ogden. Yep, I went to Weber State. So yeah, a lot more snow. I do miss getting more snow in northern Utah than we get here in southern Idaho. Elaine, New Mexico. Virgil in Billings. Snow in the Puget Sound, interesting, from Skyfox 720. My dad lives on Whidbey Island at Oak Harbor, so I'll have to call him and talk about that. Gary in Riverside, Roger in Vegas, someone from Ohio, but in Washington State, Oregon, let's see, Atlanta suburbs, awesome, Snohomish. Yeah, some Pacific Northwest folks and people from some other areas. Yeah, fun seeing where everyone's from. Boise, Jim in Boise, just down the road. Shoot, Jim, you could have just drove an hour and a half and sat in my office with me, and could have got a headset for you. Had some color commentary from you. And Nicole in Vancouver, very cool. Yeah, roads were not designated for ice here. Yes, they're not ready for the ice around the Puget Sound area. So when they get that snow and ice, I'm sure it's problematic. I remember living in Fort Worth, Texas when I was in high school, and I think the Dallas-Fort Worth metro area got maybe an inch or two of snow, but it shut things down for 3 days. Like, it was just like people were not going anywhere. Let's see, Robert, Dallas. Cynthia, Twin Falls. Hey, welcome, neighbor. Dave, oh, cool question right off the bat. That'll help me from just kind of stalling. Thanks, Dave. Does the lava composition, felsic or mafic, vary between the different Hawaiian volcanoes? Does it vary with time? Good question, Dave. It doesn't vary much. It's it's all coming from one source, right? So it's all coming from this mafic hotspot way down inside the earth, down in the mantle. And so, hi, Mike from Burley. And so it's the same source, but what that magma does is it makes its way to the surface. That can play a role in some of the finer variations. I think the big the broad answer to your question would just be no, that it's all basically basalt for the most part. It doesn't vary much from location to location. But that being said, if you get some magma that's coming up and then it kind of starts to crystallize a little bit, but then some of it melts again, you can, that's what we call shoot, I just had a brain fart there. Fractionation, where you can actually get the chemistry of the magma to change slightly. And of course, if the chemistry of the magma changes slightly, then you end up with maybe some different eruptive dynamics as well. So hopefully that answers your question. But generally in this location, it's pretty much the same. Iceland's a little bit different because Iceland has some remnants of, even though it's in the middle of the ocean, it has some continental crust remnants, we think. And so it has a little bit more varied chemistry and variety in its magmas, even though 90+% of what erupts in Iceland is basaltic magma or mafic magma. Yeah, good question, Dave. Hopefully, I don't feel like I did a good job on that, but hopefully that helped a little bit. Yeah, I can talk about Pele's hair. Robert, let me add that to my list of things. I don't know if I have a picture of it ready, but I bet we can find one on the USGS site. So yeah, make sure I address that. I just wrote it on my notes here, but kind of off to the side. So hopefully I'll see it as we go forward. So yeah, a couple more minutes we'll get started, but I'm happy to answer some of these questions now. I know more folks will get on, and then there'll be a lot of folks that will watch this as a recording. From Eric, what are the atmospheric effects of the volcanic gases? I assume very little is getting. Actually, the SO2 is mostly going into the upper atmosphere. And so the VOG, we'll look at the VOG map. The VOG, or the air quality near the surface where the people are, is generally pretty good. And so based on the output of this vent and the weather conditions and the fact that the vent's at, like, I mean, if you think about it, the vent's already at about 10, 11,000 feet. And so that definitely helps it put those gases directly up into the atmosphere versus if it was a vent at sea level. And so most of these gases, from what I understand, are going into higher parts of the atmosphere, which makes air quality better on one hand, but then it also allows that upper atmospheric jet stream and wind dispersion to kind of carry some of those gases to other places. But it's still a pretty small amount of SO2. I mean, it's a lot of gas going into the atmosphere, but compared to other vents and volcanoes, it's not huge. So really good question there, Garrett or Eric. Eruption seems to be slowing down. Well, Skyfox 720, the rate of lava movements slowing down. We'll talk about that. Yeah, good stuff there. Jesus. Yeah, I'll try to address that too, Jesus. Make sure I circle back to that, how long the eruption might last. You're going to Hawaii in February. Well, you've got a better chance than I do of seeing something exciting because my trip with students isn't until May. So, what are the chances you get to see something there? It's kind of anyone's guess. All we really have to go on is past events and what this volcano has done in the past in terms of longevity of eruptions. And usually it's kind of a weeks thing. I think if you're going in February, gosh, I'd give you at least a 50-50 shot if I really had to pin down some sort of number that you'd see something. So Mauna Loa and Kilauea erupting at the same time. Here's Elaine. Is there an increased chance of magma chamber collapse? No, because they're fed by two separate shallow magma chambers. So Mauna Loa and Kilauea have their own plumbing systems. They both are tapping a deeper magma source, but that's way the heck down there. That magma rises. We talked about the two trends, the Loa and the Kea trend, a couple live streams ago. And so the idea is that both these volcanoes have a different connection to the deeper magma supply. And so they have their own near surface, shallow magma chambers that feeds them lava from those magma chambers. So not worried about collapse. And usually collapse is more when the lava gets fed away from one vent into another, that's when you can get more collapse at the surface. That's what we saw in 2018 when the Pu'uo'o area on the East Rift Zone, that lava had been there for 30 plus years, and it all moved away within a matter of hours. It moved down the rift to the neighborhood, Leilani Estates, and started erupting there. And that drainage and migration of the magma away from Pu'uo'o caused there to be some collapse there as well. So hopefully that helps a little bit. Hi, Dan. Yeah, James, collecting any lava for Tri-Valley? Well, I don't know. We'll have to see when I get out there if things work. So great. Well, it looks like it's 3 o'clock. I appreciate a couple of preliminary questions coming in on the chat just to kind of keep me occupied and keep me away from telling you probably boring stories or maybe things I shouldn't tell you. So greetings, everyone, and aloha. This is Shawn Willsey, College of Southern Idaho geology professor, someone who's been to the Big Island of Hawaii several times, and someone who is paying close attention to this eruption, not just for personal reasons, but for scientific interest as well. And I appreciate you coming back here and sharing with me. I last live streamed last week on Thursday, I think. And since then, we've had a couple days over the weekend. And so I think there's, well, nothing, huge and earth-shattering has taken place, or you probably would have seen that on the news. I think there's been some interesting developments at Mauna Loa and some more data that's come in from the USGS that might make it of interest to you, and hopefully I can shed some light on it and explain it as best I can. So we're starting here with this great live stream webcam from the USGS. So they now have, I don't believe this was up when we last live streamed, but they now have, if you go to YouTube and go to the USGS channel, you can pull up a live stream 24/7 footage of Fissure 3 right here, the primary event for this eruption, doing its thing. And so if you're someone like me, this is something you might just put on your TV or device, and depending on how the sound is, you may or may not want to listen to it. I'm not sure it actually even has sound, but just as a nice soothing visual, this is what I like to call lava therapy. But we can see the eruption coming out of Fissure 3. It's built up since the eruption began because this lava is enriched in gases, and so it's being thrown out of the vent at varying heights. You can see a big chunk coming in and coming over here, and watch this one come down, boom. So as this lava is erupted into the air and it settles or collects on the ground around the vent, that builds up this kind of cone-shaped feature here. Now from this view, it looks like a cone. And let me just maybe be real clear here. This is not a cinder cone, which is a volcano some of you might know about. This lava is too, I guess for lack of a better term, wet. It's not gas rich enough. And furthermore, the other thing is that the shape of this vent, if you could see this in a more three-dimensional view, you'd see it extends further away from your view. So it's more oval shaped. So this is what we call this material that comes out of the vent, this sticky lava that is being thrown out by the gas coming up with the magma, that kind of sticks and coalesces around the vent, adding mass to this cone or this rampart. We'll call it that here in a second, around the vent. This is what we call spatter. So very non-scientific term. So this is lava spatter. And so this lava spatter sticks to itself as it hits the ground. It's very hot, so it forms a material we sometimes call agglutinate. If you need that for spelling bee class, it's agglutinate, agglutinate. And what this forms is a spatter rampart. If it was just a singular vent coming out of like one spot, sort of a nozzle effect, making a more symmetrical cone, we'd call it a spatter cone. But because it's more elongate and erupting along a fissure, it's what we'd call a spatter rampart. So there's some fun definitions and words for you today. But you can see some of the lava that's coming back down into the vent that stays quite hot and fluid, if you can just make it out coming out through this breach here and feeding this lava channel that kind of flows off to the right here in the foreground. If you tune back into this in, well, shoot, they're in Hawaii right now. It's what? It's noon. So I guess what, maybe 5-6 hours from now would be a good time to maybe tune back in when it's getting darker, because then you'll see more of the incandescent glow that most people get pretty excited about. But this new live webcam is up, so that's there for your pleasure in viewing entertainment. So let's go to let's go to some photos here and some maps that kind of show where we're at with the eruptive sequence. So here's the latest USGS map from yesterday. They haven't put out a new one for today. And what we can look at here is, so the lava flows that have occurred since this whole eruptive sequence began. And we're about a week in, right? It was a week ago today that I did the first live stream because the eruption had just started. Yeah, is that right? Yeah, it started on the, no, I got my days mixed up a little bit. Yeah, it started on late Sunday night into Monday. So that was kind of exciting. But what we can see here, if I can zoom in just a little bit, is you can see that Fissure 3 is the only active vent. We had previously had a couple other vents as well that were open. We had Fissure 1 up here, Fissure 2 up here, and then most recently we had Fissure 4, which was feeding these flows here. But Fissure 4 is now dead. So rest in peace, Fissure 4. We enjoyed you while you were around. And Fissure 3 now is the primary vent, the only vent for this eruption. And most of its lava, again, coming out of this elongated fissure, forming a spatter rampart, is feeding lava channels that are moving to the north. They've crossed the observatory road some time ago. Again, they're starting up here at between 11 and 12,000 feet. And they're down here currently about 2 miles south of the Saddle Road. And so this is, of course, the primary interest for a lot of folks, not just on the island, but elsewhere, because this is the first real threat to any infrastructure of significance is the Saddle Road down here, or to the north here, Highway 200, which connects the Hilo side, the east side of the island, with the Kona side to the west. So this is where it was as of yesterday morning. If we had today's on here, it would just add like a little bit of a smidge there. And we'll look at a comparison here in a second too to see what this looks like here. But I want to actually kind of go back up to the summit because they actually were able to add in with some satellite passes. They were able to get some of the imagery for the flows that happened the first day. So remember the eruption began in the summit caldera, and then it migrated, the magma migrated down into the northeast rift zone. And so now we're kind of fixated on this fissure 3 in the northeast rift zone. But we did have fissures, there was a line of fissures here in the summit crater or caldera. Let me get the pen working here. Yeah, so there was, kind of a set of fissures coming across here, feeding these lava flows into this area here. There were also a few fissures here that were feeding lava flows. We can actually see one that actually turned the corner and filled this old pit, this old crater here. So it partially filled part of that there. And then you can see sort of the elongate nature. So there was probably, maybe not one continuous fissure, but several fissures up through this area here. Let's be real careful because this is not, even though we have some eruptions that were taking place when this all began that were to the southwest of the summit caldera, that this is still considered a summit eruption, all these fissures that were opening up here. And that's because what we have here is we have this obvious central caldera or pit near the summit. But this is actually just the deepest and most noticeable, I suppose, pit. There's actually a bigger structure. You might even be able to pick out this topographic break here. It gets a little murky over here on this side, but it comes around something like this. And so that actually defines the greater summit caldera, just like we'll look at Kilauea later at the end of this live stream. But Kilauea also has sort of these nested calderas or depressions near its summit. And so these were all still within that summit eruption that began initially when the eruption began. So there's our USGS latest one. I'm sure they'll put out another one later today, but it'll probably just be another little thin veneer of red around here. But nonetheless, we can see that the flow is not only advancing more to the north, but it's actually getting wider, which is what we'd expect as it's starting to move into this flat open topography. Is that the leading edge of this flow front is not going to it's not going to move as quickly to the north, but it's actually going to start to fan out a little bit as it moves that way and spread out over this open topography here. This is a pretty cool view here. This is, let me zoom out so you can see the whole thing. So these are 3 thermal maps that they have done with satellite imagery from November 30th, which was what, last Wednesday. So Wednesday, Thursday, Friday of this past week. The way these work is that the orange and reds are the hottest rock, and then the kind of yellows and going into blues are the coolest. And so if we start with last Wednesday, if you zoom way in, you can actually see some of the orange here. But the whole point here is you can actually see, let's zoom out and get the big picture. So if you look at the 3 images, you can see that not only has the flow moved further to the north, not much, but a little bit each day. And we can look at the scale here to see how far it's moved. But it's also become much wider. And you can also see some of the changes in the geometry of the braided channel pattern of the lava further up in the channel itself in the lava flow, which is kind of interesting because this is giving us real good information about how this lava flow is kind of changing, not just linearly in one direction, but also laterally to some degree as well. There's a big swath missing here. Maybe they're missing data from the satellite imagery. There's obviously the fissure down there. I can point out a few things here with the little markers. So there's fissure 3 right there. Fissure 4 was active at that point, and that's probably right in here. So feeding these flows that came out here, this flow that went this way, an abrupt line here. So missing some of the data from the pass with the satellite. And then over here, we can see the braided channel network. And then this is classic here, the way that this thing sort of is lobed out and expanded. You can see there's places in here where the active channel is still quite hot and forming kind of a narrow zone, but then there's these wider zones out here. And then you can even see places where it's maybe overflowed, forming a secondary branch, like we see here. There's another little kind of lobe here where it's kind of broken out of this channel. And this is kind of common. We don't expect these, not like a river where its path is somewhat the same unless there's a flood. We expect these lava flows to change quite a bit. So this little secondary channel here was actually abandoned, but you can kind of see this faint lightish blue signature there. So you can see it kind of is still preserved, but it cooled off quite a bit during that time. It looks like this channel, which was kind of branched out a little bit from some overflows. Maybe the channel had some overflows or breakouts that caused it to spread out laterally. Literally a day or so later, it kind of reorganized and become much more linear and direct in its path. You can still again see vestiges of these older flows out here with these kind of ghost looking kind of shadows here. So really cool imagery. I could probably spend another 10 minutes just looking back and forth at these and looking and comparing. But that's probably good enough for now. Let's see, what do I have next? So let's go to the Hawaii County map, their sort of hazard map that kind of, this is what the government agencies are putting together. So again, looking back up at the top, so here's the summit area, the flows that spilled over into the southwest the first day, those now are completely inactive. Of course, they've got the 4 fissures showing up here, but we can obviously go ahead and kill these 2. Fissure 1 and 2 died several days ago, and as of yesterday, fissure 4 is also dead. So fissure 3 is the only game in town right now, the only fisher that's still active. And we can see it's forming flows that are moving, that have moved, whoops, sorry there, to the north, crossing into the Pohakulua training area. This is the military training area. Most of their infrastructure is outside of where the flow is, but we can see, the expansion a little bit in here. It looks like it's going to reemerge. I believe this is part of the forest reserve, this little chunk of land here. And we can also switch this over to, yeah, that might be better for some folks instead of looking at the land ownership map. But we can see it's generally following this eruption, and I think this was the 1935 eruption, right near the border between that and the 1843 eruption. We can, and again, it's about 2 miles from the Saddle Road. Let's switch over to Kit Tincher's maps, because his maps are really awesome and really helpful. So here's his latest map, kind of orienting you again. Caldera at the top, fissures 1, 2, 3, and 4. Fissure 3 is in bold because it's still the active one. Here's our lava channel and our main eruptive path of importance. And we can see, November 28th, about midday, it was here. A day later at about the same time, it had progressed all the way to here. But then you can see it really starting to slow down as we go into subsequent days, right? Here we are on the 30th November. And then it looks like they just have been updating this, or he's been updating this in the morning of each day. So 6:30 on the 1st, the 2nd, the 3rd, and the 5th. And you can see these last 2 points are really close together, just to emphasize how how slowly this flow has been moving. Again, right between these two lava flows, and also somewhat straddling now this dark blue line, which separates these two inundation zones. So what this dark blue line is, if you're new to this map, is it's sort of like a topographic high or a saddle or a ridge line. Basically, if we get more lava spilling to the left of that blue line or to the west, then the lava is most likely to follow a path that takes it down to the west towards Kona. If we have more of the lava supply going over to this side, to the pink, to the right or the east of this blue line, then we would expect that lava to follow a path to the east, pretty much down Saddle Road, and possibly heading, down towards Hilo in the ocean way down here. So great map from Kit Tincher again, who I believe used to work in Hawaii. One thing that has been added, so there's so many people that have been heading up there to try to get a look at the eruption. You can imagine, I think, there's a couple 100,000 people on the Big Island. And even though it's the Big Island, it's still an island with sort of, most of the island is just Mauna Loa itself. So everyone's kind of crammed into some limited space to some degree. And so with the tourists and the residents, there's been quite the excitement of going up there to witness the eruption. And what they've actually done to kind of alleviate all the congestion on this highway and keep accidents from happening and such is there's this is the old Saddle Road, and they're allowing cars to come in on this in a one-way kind of orientation and park along here and then look up at the eruption there. They don't want people, and this is important, hiking out to the lava flow itself, even though it's not too far, 2 miles. It is one over pretty rugged terrain. These are old lava flows themselves. And so it's incredibly rubbly and irregular. It's kind of ankle breaking type of topography. And 2, part of the flow is sitting in this military training area. And so there could be unexploded ordnance. I saw a post this morning. I didn't dig back into it. If someone knows, they could put something on the chat, but that the road was closed for a while. The viewing road was closed for a while because, again, this is second or third hand. I don't know how factual this is. There was possibly some unexploded ordnance that was found because someone hiked out there, right? So it always turns up where we just get a couple of people that aren't so bright that kind of ruin it for the rest of us. So people had left, at least allegedly, the viewing area road. And so the military had to kind of shut down that for a while until they could take care of whatever whatever business was going on out there. So anyway, but this is Kit's map here. Remember the squiggly lines are the contour lines. The next big topographic feature that it's sort of probably going to head towards, and I'll show you this in the next map here, is this hill, Pu'u Hulu Hulu. So Pu'u in Hawaiian is just hill. Hulu Hulu means hairy. So this literally is hairy hill, and you'll see why in a second. This is an old cinder cone that's revegetated. So it's had some vegetation grow back on it, but it's surrounded by these older lava flows. And so it kind of looks like a hairy little hill. It actually has some endangered species, and they've been working to kind of revegetate it. But if this keeps up, there's a good chance the lava flow will kind of head around the base of that old cinder cone. Let me see, anything else to point out here? Again, it's still quite a long ways from Hilo. We've been erupting for a solid week now, and this is as far as the lava has progressed. So it would take many more weeks at the current rate to get the lava flow all the way down there. Let's go to Kit's more detailed map here. This one's kind of nice. And what he's done here is kind of used his best guess as the flows were taking place, and plotted up the possible or probable path of the lava flow. And that's what this purple dashed line is. All these little blue lines here, which looks like streams, these are actually, the USGS has mapped out what they call lines of steepest descent, meaning where the lava, if topography is the only guiding factor, and it's an important one, but it's not the only one. But if topography is the only guiding factor, where would the lava go? So you can see he's kind of plotted his path of descent right on top of this blue line here, which straddles closely the divide between these two inundation zones. So his sort of hypothesis or modeling suggests that this flow, if it keeps up, is going to head down towards the road. It's going to come around the south side of Pu'u Hulu Hulu. And then if we follow these even closer, it would turn a little bit to the northeast and then cross the road somewhere about here, just to the east of the access road that goes up to Mauna Kea and the telescopes that we have up there. So we'll have to see if that's how it plays out. It could kind of end right here. It could continue. All those things are in play in terms of possibilities. One other thing that's happening to the flow is, again, it's moving really slow at about like 25 yards or 25 meters per hour. So it's incredibly slow and sluggish. It's not advancing very fast. But that being said, the other reason they don't want people hiking out here and approaching the lava flow is there is the possibility of these flows inflating. I'm going to show you a video of what that looks like here in a second. As lava cools and crusts over, depending on its sort of consistency and viscosity, it can actually develop a flexible outer crust. And then as lava flows within and underneath that crust, it actually allows the lava to inflate like a balloon. And this is one way that lava flows can increase their height or become taller. So let me show you this little video here. This is actually, this is from Kilauea. So this is looking, this is a different part of Hawaii, but this is from maybe 10 plus years ago. I don't even know when this video was taken. This is looking up the hillside or the cliffside, what they call the Pali in Hawaii, up towards the East Rift Zone. Pu'u'o's off the video here to the left. These lava flows have come down, several miles headed for the ocean. But what you'll see here is this kind of thin, ropey pahoehoe, and this is time lapse to let you see it. See how it's filling in the low spots, but now it's actually rising. It's inflating like a balloon. More lava is being injected into it. And so what's happening is the low places are becoming the high places over time with this lava inflation. And so this is one thing that makes it difficult and tricky to be able to determine where this lava flow is just going to go. Ultimately, I'll kind of run that back. But yeah, so this is the tricky part. If it was just topography, we would be able to determine with some degree of certainty where the lava flow is headed. But because the lava behavior can include this type of inflationary process, that means that it's a little bit trickier than it might be otherwise. So I wasn't sure if you were aware of this or had seen this before, but I thought I'd throw that in there as kind of a fun little tangent there. So Okay, let's look at, let's do one more thing, and then I want to show you some photos and videos from the USGS. Let's go back to Kit's map. And so the big piece of data that's kind of been missing that a lot of people have been interested in is the flow rate in terms of like how much lava is being pumped out of the ground by Fissure 3. What is the actual supply of lava as we've been kind of looking at this thing? And that's a tricky thing to do. I want to kind of draw a parallel here. So in order to figure out the flow rate, so what we're actually talking about here is what is the volume of lava coming out of Fissure 3, Fissure 3, in terms of time, right? How many cubic feet per second or cubic meters per second or gallons per second, if you like those units, are actually being pumped out of the ground by Fissure 3. And just like a river, we measure river discharge the same way. So you might be familiar with like CFS, cubic feet per second here in America, or if you're in another country, cubic meters per second. That's a way that we can quantify and tell how much water is moving down slope. And so to be able to do that with these flows, what we need is a couple things. We need to know the, let me turn on the drawing tools a little bit here. We need to be able to figure out the width of the channel. So if we come down here to this active flow, and let's say maybe the whole thing's not active, but let's pretend it is. So we need to know the distance across the channel there. Let me change the color so you can see it a little better. So we would need to know the width of the channel. That can be measured. That's not a big deal. We can do that with satellite imagery. We don't even need to send people onto the ground. We can pick different parts of the channel and we can measure the width. The second thing we would need to determine is the velocity. So I'm not sure how they do that. They may need geologists on the ground there, but we need to quantify to some degree how many feet per second, or meters per second, if you will, the lava is moving as it's moving down slope, right? So just like your car measures velocity in miles per hour, kilometers per hour, same sort of thing. So we would need to figure out those two things. We need to know the velocity, which they can determine. That's not hard at all. So velocity, and we would need to times that by the width of the channel, which again, we can measure. And I'll keep these in metric units for now, but you could easily turn these into English units if you like. So that'll be meters per second, the width of the channel in meters. Okay. And then the final thing we need to know, and this is the tricky one. So to get the discharge or the rate, which would be in either cubic feet per second or cubic meters per second, again, whichever you like. Notice we have one unit of meter, we have a second one, we need a third one. So the third thing we need in order to really calculate and quantify how much lava is coming out of Mauna Loa right now is the depth of the channel. So if you think about it this way, I'm going to draw a little picture up here. So if we have a lava channel that looks like this, okay, and this could be a river too, this is the same sort of thing. So here's the lava pouring down. Here's a little person for scale, although I wouldn't want that person standing that close to the lava. Boy, I gave him a squished head. Sorry about that. But what we'd want to be able to figure out is, okay, what is the average width of the channel? Or no, sorry, not the width. The width we have. What we'd want to figure out, sorry, is the depth of the channel. And that's the piece of data that we just can't estimate with any degree of certainty. So if you think about this, this is lava, right? There's no way to put a stick in it and see how deep it is. The other thing we don't know is what the channel shape looks like. So does it look like this? Or is it maybe like really deep here and it comes up and maybe it's shaped like this? Who knows, right? But at any given point, if we could measure the width and the depth, the average depth and the velocity, then we can get the flow rate. So this stuff here, boy, this is a terrible math problem now, will equal the flow rate. Sorry, that's supposed to be an F. Or what we call in rivers and stream terms, we use the term discharge. So we have an estimate now, long story short, and the estimate the USGS has given, at least recently, is about 50 to 100. Notice that's quite a big span because, again, we don't know that depth measurement as well as we'd like. cubic meters per second. So every second that goes by, there's about 50 to 100 cubic meters of lava being pumped out of the ground by Fissure 3 or moving down the channel, if you will. And if you don't speak metric, like a lot of folks in America don't, well, what does this mean? Can you turn this into numbers I might actually comprehend? This is about, if we change this to cubic feet per second, I won't write it out here, I'll just tell you, it's about 1,700 to 3,500 cubic feet per second. Or if we turn it into gallons per second, which might be a unit you're more comfortable with, it's around 13 to 26,000. So about 13 to 26,000 gallons of lava are being pumped out of the ground every second by Fissure 3, which is pretty impressive. So hopefully that helped a little bit. I didn't mean to turn that into a math class, but you might have been interested in actually, how do they figure that out? It's just velocity, it's width and depth, and we can determine the flow rate, or at least estimate it to some degree. Yeah, so tricky stuff. But at least we have some estimates now. And so with that estimate, and that can change, right? It could start pumping out more lava over time. It could slack off a little bit. So that would be something that they want to try to keep estimating as time goes by, because that really is the biggest variable in terms of how far this lava gets and where exactly it's going to go. So, okay, let's go to some videos. We've been looking at maps for a while. Thanks for hanging in there. Let's go to, yeah, some videos. So each day they put up a series of photos and videos for the day. So I picked the ones from yesterday. There is ones from today, but I thought there were some good ones here. So some nice photos here. I won't click on these. This is something you could go back to if you want to and look at some of the photos the USGS has kind of put out there. What I want to show is a couple of the videos here. So this is Fissure 3 erupting yesterday morning, Sunday morning. And it says here, lava fountaining at the event was about 100 feet tall. So when you see these little clots or blobs, or what we call spatter, lava spatter, go up into the air, the highest ones are going up about 100 feet or 33 meters tall. And then those fall back down around the vent and start to build up the spatter rampart here. But there it is erupting, kind of a cool view. Again, you can see some of these being tossed out onto the slopes. I'm going to go back and actually show you that again. Watch some of these clots here. Watch my little cursor here. Here's this big one right there coming over the side. And then boom, you can see these red incandescent pieces of lava hit the slopes on the outside of the cone. So whenever the lava goes outside the vent and outside the cone or the spatter rampart, that's just adding more and more mass to it itself there. This one, I think we'd seen something like this before, but a nice view in the evening of Fissure 3 and the lava flow coming down, heading off to the north there. You can see some of the steam from some of these older flows here. This is an older cone here in the foreground. I think that might be Dewey Cone, if I remember right. It has a name. That's from an older eruption. Short little video loop, but pretty fun. And then this one here, let's see what I want to do with these. Let's just go through a couple of these. Oh, this is the one we just saw, so let's not look at that. And that one might be the other one we just saw. It's just different. This might be different. Let's see. You can't get enough of erupting volcanoes, at least I can. I think that's the same one we saw. Yeah, there's those clots coming over the rim, adding to the spatter rampart. The lava channel further down slope, as you can see, the main channel being quite liquid, hot. But when it overflows or backs up, it can spill out onto these adjacent areas. And this is one way the channel width can change over time as these eruptions progress. It can also get kind of blocked up. Sometimes it rips off a wall of this channel wall. It can clog up the entire flow and send the whole flow into a different direction. So really crazy how many variables there are in this. This is a little bit older one here. I think if you could compare all these, you might be able to see the spatter rampart kind of growing over time. So again, just the eruptive vent there at Fissure 3 and some of the spatter accumulating on the outside. Yeah, so I won't go through all these, but if you're interested, all sorts of cool little short clips from it erupting. That one looks pretty dramatic. We might have seen this one too. This was from last week. Yeah. Get us to the good stuff. There we go. Yeah, spectacular. So there's Fissure 3 in full force. And then the flow is heading down. This was last week, though. We've seen that. Let's see, what else do I have for you? We talked about the flow output. Yeah, I think that's all I got for photos and videos. I want to look at some of the monitoring data. So let's look at earthquakes for the past week. Let's go ahead and update that. I think it updates on its own. So this is actually the last day. So what have we seen in Hawaii during the last day, at least for Mauna Loa? Few earthquakes up at the top. Remember that initially the magma started here and then it moved into the Northeast Rift Zone. And so as this area then deflated. So the magma came in here, erupted here initially, but then the magma moved under the volcano and started erupting down here to form Fissure 3. And so because we had that initial influx of magma into the summit region and then subsequent withdrawal and movement away from it, we're getting some small earthquakes here. So this is probably related to the deflation and the withdrawal of the magma over the last day. The summit region is still adjusting to that change, even though it was a couple days ago. And we'd expect that to continue, right? And as seismologists look at these earthquakes, they'll be able to tell which earthquakes are indicative of magma inflating or coming into the system versus leaving the system. So a couple here, looks like one in the last hour down here. We don't worry too much about an isolated earthquake kind of out there. This could just be little changes in the entire mass and bulk of the mountain, adjusting to some of these fissure eruptions and these stress and pressure changes. That's what probably some of these outliers are here. But we can also see earthquakes around Kilauea. I want to come back to Kilauea and talk a little bit about it at the end here. And then the Pahala area earthquakes, which we've had for quite some time as well. So that's the last day. If we look at the last week, it'll be a lot more impressive because it'll include a lot more data. Remember, yellows are within the last week, oranges are within the last day, and reds are within the last hour. So there's that earthquake that just popped up. Yeah, sometime within the last hour, 1.8. And then, of course, the size of the circle gives you the size of the earthquake in terms of the magnitude of the quake. So 2s and 3s mainly. I think there was a 4 in here somewhere tucked away. I'm not going to bother to look for it. But anyway, so there's some of our earthquake data. If we look at the earthquake data from the past week in sort of a different context, so a similar map here, summit region of Mauna Loa, heading off into the Northeast Rift Zone. What do we have here? Oh, the depth of the earthquakes. So the locations, this is basically a cross section of this little map here. So there's the top view. Here's the side view, mostly shallow quakes, right? So associated with magma breaking the rock near the surface. Past week, so here's everything ramping up as these earthquakes have happened, but then we see them dropping off. So what we can say here, yeah, let's stay with the earthquakes for a second. Lots of earthquakes when the eruption began, and then not so many. So what we can say then is that, what does that really mean in terms of what's happening with this eruption? It means that the eruption's pretty well established itself, like at least for this point in time. We had the big event take place when it started near the summit. It's moved now into the Northeast Rift Zone. And the fact that we're not seeing a lot of earthquakes here suggests that the magma's not moving around. It's staying put. It's staying at Fissure 3. It doesn't seem likely that it's moving down the Northeast Rift Zone because we'd expect to see earthquakes progressing in that direction along with other signals. We're not seeing that. So right now, we would not predict any eruptive behavior different than what we're seeing currently. Which is good news. That's good for people in Hawaii for sure. And could that change? Of course it could. And we'd expect the earthquakes to be among the first pieces of evidence we'd see that suggest that's changing a little bit. Deformation data. So this is the tilt. So this is back on November 28th. So that's when the eruption began essentially. So there was inflation, basically the mountain inflated because magma was rising to the surface. It erupted, and so after it erupted, we see sort of a deflation trend there. So now that the surface is coming down, and these are in very precise microradian units. It's not moving up and down anything you'd really be able to see detect, or well, we can detect it, but it's nothing obviously visible or of high magnitude. It's pretty small resolution type movement there. So that's some of the monitoring data over the past week or so. I mean, we could also look at the past month. This is kind of fun because you can see, here's all the earthquakes happening in November. Here we are at Thanksgiving eating turkey, and there's just, a few, and, like 50 a day. So the blue this is 50 per day, this bar graph, a little bit more than 50, a little bit less. And then boom, here's the actual eruption. But notice we've dropped back down to more or less pre-eruptive levels in terms of earthquakes. And so we don't expect anything to change unless we see a change with that. Same thing with the tilt. When you plot it out over a month, it's a little more dramatic, that inflationary increase as magma moved up towards the summit, and then the magma erupted as lava, and then we see that decrease there. So kind of cool. And you can also plot this up over the past year, 5 years, if you want to do that as well. Kind of fun to see that. Okay, let's look at one more thing on Mauna Loa. I pulled up this is the VOG map, and I don't know a ton about this, but it looks like, again, it's just based off the weather patterns. It doesn't look like they expect it to be hugely significant. And remember, this is the surface measurements, the air quality measurements they're seeing are still in the healthy category. So at least with the way the atmosphere is dispersing the SO2, the sulfur dioxide coming out of these 2 erupting volcanoes, it doesn't seem to be causing any health issues to the communities in Hawaii. So that's good news. So it looks like we've switched from a little bit from the dominant trade winds to now things are kind of blowing off a little bit more to the northwest, it looks like, just based on the dispersion pattern there a little bit. Okay, and then I thought we would also switch gears here. I think that's all I had on those, yep. And look at, because I feel a little bad. I feel a little guilty as a geologist and someone who is a fan of Hawaii's volcanoes, because my whole life I've given this volcano my devotion, my attention. I've given it some boot rubber walking across its surfaces, and now I feel like, I'm breaking up with someone. Like this was my girlfriend for all these years, and now there's this more attractive thing that's kind of come my way, and I'm ignoring it. So I do want to spend some time, just a few minutes here as we wrap up, and then we'll go to any questions you might have. Looking at Kilauea, which has been active since 1983 continuously, and of course it has a period of eruption preceding that, but in modern times that's the big period of time. But it's also erupting. So while we uana Mauna Loa, we should also think a little bit about Kilauea. And so Kilauea sits here. This is its summit caldera. And just like we talked about with Mauna Loa, you can see that there's a broader region that has collapsed from other eruptive events. But then within that, there is a smaller crater. This is called Halemaumau. And this is the vent that's erupting today. Kind of zooming back out, this is the, let me get my bearings here. This is the National Park Visitor Center area over here. This is the Kilauea Military Camp, a vacation facility that the military owns right on the rim of the caldera. And this is the USGS Volcano Observatory over here. I thought we'd look a little bit at Kilauea as well, and just give it a little bit of recognition, even though we're doing these live streams because of what's happened with Mauna Loa. I wanted to still maybe let you know that there's another volcano that's also erupting. So here's our video camera live streamed from Kilauea, and this is that innermost pit on the west side, and it's sort of convecting and pushing up an active lava lake. So you can see that incandescent glow today. You can see a little bit of it under there. This material here is still lava and hot. It's just partially crusted over. I think at night this would still glow a little bit, or at least along the cracks, if you will. And so it's still erupting at Mauna, or at Kilauea. Let's see, what do we have here? So here's another kind of view of that lava lake. You can see some of the glow here. around the edges. Again, during the daytime, it's a little harder to see, so you can come back to these webcams at night. These are just still photos though. A little glow there from this little vent at the summit. And then this is kind of cool here. This is actually big picture view. I think this is probably the better place to start. So here we have the USGS Hawaii Volcano Observatory, Kilauea Military Camp, the Visitor Center for the National Park, the edge or the rim of the Kilauea caldera here, this smaller pit here, and then this actually shows you with this thermal imagery where the active lava lake is. So you could, if you're at Kilauea in the evening right now, you could still be seeing the glow from this lava lake up there. Now the lava lake has actually dropped a little bit. It's been kind of slowly descending. Sometimes it goes up and down in this little pit it's trapped in, as much as a couple 100 feet over time. But right now it's actually dropping slowly, about 1 meter per day. But if we look at, well, what is Kilauea's, what's happening with its monitoring data? Well, not a lot. Like, it's got a tiny bit of deflation at the summit. You can actually see right here, there's this is the tilt at the summit. Oh, and the East Rift Zone. So some of these little spikes that come down, like this one here. So this is the last day. This is looking at it the past week. So these are 2 different graphs. That's just for the summit. This is looking at tilt over both the summit and the East Rift Zone. But it's that little spike right there is actually when the eruption began on Mauna Loa. So that kind of jolt or that initial earthquake was actually caused a tiny movement at Kilauea's summit as well, but it didn't trigger anything. So even though this looks erratic, you can see there's kind of an overall background here. And remember, these units here are super small and precise. And so none of this seems to indicate that there's anything going on at Kilauea. It is following a trend, if we go through this year, of inflation. So it is very slowly accumulating magma over time. And you can see that this kind of goes up and down. This isn't a perfect, this kind of varies a little bit up and down. There's some daily fluctuations in here. Past 5 years, this is just the last year. This is 2022 data showing, when it's moving upwards, trending upwards, that means the distance between 2 points on the summit are moving apart. So that means it's inflation, that the magma is pushing the ground apart. If it were trending the other way, it would mean it's coming together, those 2 locations getting closer. If we look at the last 5 years, though, this is pretty awesome. What you can see here is the big 2018 eruption. So what happened in 2018 in May or so was the magma at Kilauea's summit there was a drastic deflation event. So the magma moved away from Kilauea and down into the East Rift Zone. And that's what this big downward trend is here. So when the magma moved away from the summit of Kilauea, it caused these 2 GPS stations to move towards each other because it was the whole summit was deflating. And then over time, once that eruption at the East Rift Zone was more or less over, you can see this slow upward trend. There's a few little dips in it, but a slow upward trend in inflation, which continues today with this little trend here we see. Pu'u'o, same sort of thing. If we come to Pu'u'o, which is a cone on the East Rift Zone, it actually had an initial inflation, then deflation, again associated with that 2018 eruptive event. So yeah, we could dissect the some of that stuff, but the whole point is that Kilauea is still there. It's still active. It's still erupting. It's just not showing as many of the dynamic changes that we're seeing here at Mauna Loa. And so I want to conclude with this here. I think on our last live stream and in my class today with my students, we talked about this. And so I think this would be a good topic to discuss, because ultimately, if you're looking at this from a public official standpoint or anyone in charge of the thing, I mean, the big question is, well, it's all interesting. Right now, it's a bit of a tourist attraction. And right now it's not impacting any infrastructure. Of course, we'd like to know how much lava is coming out. The golden question, of course, is how much lava does it have to erupt? And that's not something we can really ascertain with any certainty right now either. But ultimately, like, what's going to happen? Like, what what are we going to do about the saddle road? Is it going to get to Hilo? I think the chances of it getting to Hilo, just again, looking at the pattern of past eruptions, is really small. It was only the 1880 eruption, when Hilo really even wasn't much of a community, that got that far. In 1984, which is shown here with this this kind of bluish one here, it only got to about this point. But I think of more immediate concern is, of course, like the saddle road and what to do with the saddle road. And in my class today, I know on the live stream, someone mentioned like, well, what about moving it further to the north? And so I did find out some interesting information about possibly moving the highway to the north. And the problem with that is not so much logistical as it is economic, and more like kind of a human impact thing. So this is the part of the road. This part of the road up here is in pretty good shape because it's above these older flows. It's actually, let's see what elevation right here, about 6,500 feet. Down here at like 64. And so the road is probably high enough over there that we're not in danger of any lava flows, but you wouldn't have to move it very far. The problem with moving the road, even a couple hundred feet to the north away from these older flows and up onto the flanks of Mauna Kea is mainly that there's several landowners that own the property there. So some of it's like state land, some of it's federal land, some of it's private land. And so it's not an insurmountable task, but obviously it would take some time and wrangling to get everyone on the same page about rerouting the highway through some parcel of land that might be theirs. And so that's not too logistical. My students brought up some interesting, here's Pu'uhuluhulu, just to kind of show you this little old cinder cone that's partially vegetated, sort of surrounded by these older historic flows. So if our flow continues, the path it's most likely to follow is to come around here on the south side of it, and then come over here and cross the saddle road somewhere in there. But the other thing about moving, so there's other ways to sort of, for lack of a better term, fight lava or combat lava. And so one of my students said, well, hey, why don't they just get out ahead of this flow, get some excavators and some heavy equipment in there, and just dig a trench and take the flow away from the saddle road and down to some other location. And that sounds like a pretty good idea, but there's a couple inherent problems with that. One is, timing. Could you really excavate and put some sort of trench in? How deep would the trench need to be? The lava's got to go somewhere. Where are you going to take it? I mean, ultimately downhill is that way, so it's got to go that way to some degree anyway. So there was that issue. And then another student said, well, why don't they just, dump water on it? And I think the main issue there is there's no surface streams. There's no wells up here that I'm aware of. There might be a few shallow wells, but there's just no good source of water here. And if you were helicoptering water in from the coast and dumping the water on the lava like it's a wildfire, this stuff's 2,000 degrees. It's way hotter than water. And what if this lava is flowing for 3 to 6 months? Like it would just be a logistical, it's not sustainable, right? And then I think the third thing to remember, and this is what I brought up to my students, and having been to Hawaii a few times, I've learned more each time about the Hawaiian culture and the way they kind of view the land. I think there would mainly be some cultural objections to doing anything to reroute or stop the lava. The Hawaiians hold their land very sacred. And so I think before you would even get in here and start digging up a trench or some sort of diversion structure, there'd be some public outcry against that. And they sort of, their mythology is wrapped up in, this goddess Pele, who sort of controls these volcanoes. And I think they very much ascribe to the ideology that the lava is supposed to go where it goes, and we have to adapt and deal with that. And so I think they would definitely have some cultural objections to any sort of structural remedies or mitigation plans to reroute the lava or do something like that. So we'll see where it goes. We'll see how far it gets down towards the saddle. It's creeping slowly. So who knows how long it'll take. My plan moving forward with the live streams, I think, is, I don't know, like maybe it'll turn into a once a week thing. Whenever I feel like I've got enough information to share, then I'd love to share that with you good folks if you're willing to entertain that. And so just look for posts on the community tab on YouTube. Those of you that might be following me on my Facebook page, I can try to post stuff there as well, but you can try to catch those as well. So yeah, I've been talking for a while now. Let me scroll back and see what questions you folks might have had. We had about 180 people today. That's great. Good to see all the support and all the interest. I'll go back and look and see where everyone's from. Let's see. Yeah, how long? Yeah, some of these I talked about right before the live stream got started. How long the eruption is going to last? We just have no idea. All we can really go off of, to some degree, are these historic eruptions and how long they lasted. And I think the best case scenarios, we're looking at maybe another week or 2 or 3 or a few more of it doing what it's doing. We might see some signs in the earthquake activity if they can measure the flow rate a little better and get some handle on that. We might see some changes there that might indicate it's kind of waning. It looks like David Newton has replied to a lot of these, so I appreciate him helping me out. Yeah, thanks for helping me out with some of these questions here. Let's see. I'm scrolling through these quickly, so if I'm missing yours, I apologize. I'm just looking for any new hotspots appearing or similarly, or any old ones disappearing. If you're talking about just on Mauna Loa's surface, none. If you're talking about the Hawaiian hotspot, no, other than, I mean, the big one off the coast, right, which was called Luihi and now has a new name that I can't remember. But yeah, if you're talking about just hotspots in terms of like vents or flare-ups on the volcano, nothing there. Yeah, people liking the maps, I appreciate them as well. David's doing a great job answering some questions. Yeah, Dan's question about erecting a barrier, I think I kind of just addressed that a little bit. I think the native Hawaiians would not, I don't think that would go over well. I don't think so I haven't heard of any plans. You know, even when we had the 2018 eruption, unfortunately down here, if I can get there, in Leilani Estates, that, where am I at here? Oh, here we go. That took out parts of the neighborhoods and such down here. You know, that it was tragic. People were not thrilled about what took place there. Let me find a better image. There we go. That one's pretty good. Yeah, you can see. So yeah, you can see the roads that were there. Well, they're still there presumably, but yeah, so there wasn't much. The only thing they did do in 2018, and this wasn't, you know, fighting the lava or diversion or anything, but they did, recognizing that this flow had the potential to take out a couple of highways and potentially isolate some people in some areas. What they ended up doing, I believe this is correct, is they sort of, as an escape route in case some of these people became isolated, the old road that was along the coastline here, they actually regraded it. Now, they didn't pave it, but it was put back in as sort of a gravel road that connected Highway 130 here in the Kalapana area over here to the Chain of Craters Road, which comes up, zigzags up the hillside and goes into the national park. So they did do that a little bit. So who knows what they'll do here in terms of, you know, rerouting the highway if that needs to take place. Yeah, so I'm sure there's conversations about some of those things happening. I just haven't heard about any of those things yet. Yeah, Travis, is this thing like going to end any day now? Could. It could, you know, it could fizzle out quite quickly. It could die out within a day, possibly. Yeah, 3 out of 4 fissures, right? So, right, but remember, there was never, well, there was 4 erupting. Yeah, that's true, Travis. We had 4 fissures erupting. This is actually kind of common though with these fissure eruptions, is the fissure eruptions don't tend to last that long. generally, and we saw that in 2018, right? We had a series of fissures opening up in Leilani Estates. Ultimately, even though there was a series of fissures, and you can kind of come in here and see the dead areas and some of these tiny little lava flows in these neighborhoods, but ultimately fissure 8, and I think there was like 20 something fissures that popped up at over a period of time with this eruption. Get rid of the roads there. Ultimately, fissure 8 became the primary vent that erupted most of the lava during that eruptive phase. And so we might be seeing that a little bit here with fissure 3 kind of being the main one that kind of takes off and takes over. Yeah, and there's David saying the same thing. Thank you. So that's good to see, seeing someone agrees. Let's see. Yeah, maybe I'll have you guys, I know when Nick Zentner does his videos, people put it in caps. That might be helpful next time too, because it's hard for me to kind of find the questions when it's all small lowercase. Looks like David's handling a lot of these, which is helpful. If I have anything to add, I can go back and maybe add a comment to them as well. But how high is the spatter cone from Tom? I think it's maybe about 100 feet tall. That's, or 35 meters, something in that range. And it's technically a spatter rampart, not a spatter cone, although that's a bit of semantics there. We can call it a spatter cone. That's fine with me. People talking about tumuli or tumulus. Yeah, we can look at those. Kilauea could, Kilauea. Yeah, it's kind of the little kid. It's been the rebellious teenager for all these years, and now it's getting upstaged by its older sibling. Let's see. Quickly trying to wrap this up by checking for anything else that, let's see, what's your prediction as to whether the lava will actually reach the road? I mean, I have no idea. I'm right there with, all the USGS and everyone else. So, and definitely if I'm working for the USGS or my job's tied to making predictions and statements, like I'm really careful with my words. But since I'm not, like, I think it will very likely, I think there's a good chance it gets to the road in another week or so. But, I similarly wouldn't be surprised if it didn't. So yeah, I wish I could give you a good answer there. Yeah, Skyfox 720. Sorry, I wasn't able to help there. Let's see what else. Anything out of the ordinary in the geochemistry of the lava? Oh, the one thing that this is important to point out. So they actually have sampled the lava, the flow front here. And I don't think I mentioned this. Maybe it's obvious and you knew this without saying, but I'll say it anyway. And that is, as the lava moves downslope, it's slowing down for a number of reasons. One, it's getting cooler, right? Some of that lava is cooling off around the margins. Two, as we talked about, and maybe primarily, it's going through this low relief kind of flat ground. But three, remember that when lava cools, it starts to crystallize. And as it crystallizes, that makes it even more sluggish and slow. And so they've actually been able to take samples near the vent, near fissure 3, and they essentially had no microcrystals in them. They were essentially bland of it was all glassy material, essentially. But when they sampled the same lava further down here near the front of the flow, they actually did find crystals. Now, when I say crystals, these are microcrystals. So this is not a crystal you would be able to see in a chunk of this lava rock if you just held it up in your hand. They're small, they're microscopic, but there are little crystals of olivine and plagioclase in there. The other thing they were able to determine, which is pretty cool, is that this batch of magma or lava that's coming out of these fissures, and now fissure 3, is not leftover magma from the 1984 eruption. So this is not some batch of magma from 1984 that's been sitting underneath Kilauea and just got pushed out to the surface here in 2022. This is actually fresh material directly from the magma reservoir. So, and by looking at the geochemistry and that, they're able to determine that. So I thought that was pretty interesting. So hopefully that's helpful. Yeah. Yeah, someone saying, the appreciate, yeah, 21 miles down here. They live in Hilo. Great. No barriers should be done. Yeah, USGS says no. Yeah, and I think that jives with what I said. And it's just, I think if you don't know the Hawaiian culture well, and don't have an understanding of how these people feel about the volcano and their island and their land, you know, I think most people be like, well, wait a minute, if the lava's coming towards town, like let's move heaven and earth literally to get it out of the way. And there's a different mentality over there, and I think we just need to respect that because it's part of the culture. Composition of lava changing as the eruption proceeds. Not really the composition in terms of the chemistry, but its texture, because it's crystallizing a little bit more. So it's not a chemical compositional change, but a bulk textural change because it's crystallizing over time, at least as the flows move downhill. As the eruption proceeds, I don't know. I think because it's only been a week, I don't think we've seen any change there. So xenoliths, I have not heard that, xenoliths, but there are places on the island, lots of places where you can look at these older lava flows and see xenoliths. If you don't know what a xenolith is, it's a chunk of, well, technically it's just any foreign rock embedded in another one, but in Hawaii's context, what that means is that they might be finding particles of deeper rocks that are carried up to the surface with the magma and then entrained in the lava flow. And then as that cools and crystallizes, those can be seen somewhere. So if you look up the word or Hawaii xenolith, I bet you can find some pictures there. Let's see, could see the lava from our house. Yeah, everyone looks like, yeah, 5 different observatories. David's helping out there. Great. Yeah, xenolith equals foreign rock. Perfect. All right, I caught up to everyone. Well, that was nice. So great. Thanks for sticking around, all of you. I appreciate it. I appreciate the support. The fact that people like these, it's great because, again, I'm going to do this anyway. So it just takes me some time to put all the imagery together, to kind of flesh out a really crude script. So I kind of go in a particular order. And then just to get in front of you folks with the live stream and explain it all. So we can sign off here. I suppose a good sign off might be that there. But everyone have a great day, have a great week. I'm sure there will be, well, I'm pretty sure there'll be another live stream soon. I can't say when, so just look for some sort of notification coming up. If you like these, or if you want to see a live stream covering maybe a different topic, shoot me a message or an email. I'm open to doing that. The semester's kind of winding down here. I will get back to the rock video series. I'm going to try to do the next one tomorrow on pumice, obsidian, and tuff. So that'll conclude our igneous rock series, and then we can switch over to sedimentary rocks. I will try to get out and do some more field videos as the weather allows. We've got some ideas for those as well, but happy to try to cover anything of interest to you. Realize that logistics are a bit of an issue. So when people want me to do a video on their favorite location in upstate New York, that's probably not going to happen anytime soon. But anyway, so until next time, aloha and mahalo for all your being loyal and faithful subscribers and followers and watching the live stream. I'll get it up so people that missed it can watch it. And have a great day. Appreciate all the likes and all the things that help the YouTube algorithm machine grow, and getting more people to watch these, because it's just a fun way to reach people, fun way to connect and share my love and passion with the earth with others. So thank you so much, and we'll see you next time. Have a great day.